So hello, today we'll be doing a SAT math problem. I guess kind of hard, yeah, a little bit challenging on that challenging part. So first of all, I would like for you to pause this video and solve for the problem right now, and then you could check your answer in this video, okay? And you could see how I did it, okay? So it says in the figure above, SBT is 1/4 of a circle with center R and radius 6. If the length plus the width of ABCR is 8, then the perimeter of the shaded region is. So we're being asked what the perimeter of the shaded region is. So basically, what we should do first is label the length and width of the rectangle with variables. So let's label this as y, right? And let's label this part of the rectangle as x, right? And then we know y, right, plus x must equal to 8, right? Y plus x must equal to 8, right? And then once we know that, we also know that this is a quarter of a circle, and we know from the equation S is equal to R theta, where theta just represents the angle, like in radians, the angle in radians of the section of the circle you're looking at. So we're looking at the of course the section of the circle, a quarter of a circle, which corresponds to the pi over 2, which corresponds to that degree in pi, course, because we know pi would be correspond to 180 degrees, and this is 90 degrees. It's a quarter of a circle, to correspond to pi over 2. We know the radius is 6, so that means the arc length of SBT must equal to 3 pi. Okay, the arc length of SBT must equal to 3 pi. So we already know the length of this part. We just need to find the length of this part and this part and this part. Okay. So we know, okay, let's see what we know about this rectangle, right? We know that this triangle in here is equal to this triangle here, because there's a right angle here, right angle of course, right? And if this is a right angle, and we know that they share the same side, right? And we know that these two lines are parallel, like these two rectangle lines are parallel, so that means this angle must equal this angle. So they already have two angles that equal each other and the same side, so we know that these two triangles are equal to each other, right? So knowing that the two triangles are equal to each other, and we also know that we also know that from the distance from this point to a point, oh wait, hold on, let me make this more clear. The distance from the center of the circle to any point in the circle is basically the radius, is equal to the radius of the circle, right? Is equal to the length of the radius of the circle, right? That's by definition. So if you know that this length is equal to 6 here, right, that means that also means that this length must equal to 6 as well. I hope you understand that, right? If this length over here equals to 6, which is from point R to point B, if that equals 6, that we know that the length of AC must also equal 6, because those two triangles are equal to each other as well. By the SAS theorem, the two triangles are equal, so we know that this side must equal to 6. So okay, so from this idea, we could label SA as 6 minus y, right? And CT as 6 minus x, right? So we know 6 minus y plus 6 minus x, 6 minus x plus this radius plus, let me see, a plus 6 minus x, which is CT, plus AC, which we already proved is equal to 6, right? Which is equal to 6, plus the arc length of the circle, which is 3 pi, right? This must equal to the perimeter of the shaded region, right? So we know that this is equal to, we could simplify this as 12 plus 12 minus, 12 minus x plus y, minus x plus y plus 6 plus 3 pi, right? And we could replace this x plus y with 8. We could replace this x plus y with 8. We know 12 minus 8 equals 4, and 4 plus 6 is 10, so the answer is 10 plus 3 pi. And yeah, so that's the answer, 10 plus 3 pi. Okay, and that corresponds with answer B in the SAT problem. Okay, thank you, have a good night.